Assalamualaikum and hello everyone. We are from Group 15. Our chosen topic for CHM256 is the basic chromatography. This is our group member, Auni Akilah binti Nur, Wan Ismahani Syamini binti Wan Ismail, and Nur Amna Najwa binti Nur Azmi.
So for the presentation, we would like to talk about the introduction of chromatography, explanation that consists of theory, methodology and also result of chromatography, and the last one is conclusion of chromatography.
Chromatography is a method used to separate the component of a mixture. It is worked by passing the mixture through a material with the help of liquid or gas. Different molecules move at different speed depending on their size and how they interact with the material. So first thing first, writing color, firstly used in 19th century to separate pigments in a complex mixture. For example, if you use green dye in a chromatography experiment, your end result might be blue and yellow. You will see the blue and yellow dyes separated. So how does it work? So capillary motion will convey the mixture up the paper or cloth if it comes into touch with a container that contains a complex pigment dissolved in water or alcohol. But the pigment's constituent parts won't all move at the same speed, so it has something to do with speed for each of the molecule in the mixture. So the stationary phase will generate distinct bands of color that corresponds to each component of the combination as the smallest molecules race ahead and the biggest molecules move more slowly. Now we move on to phase and terms in chromatography. So as we can see here, there is two phases. There is mobile and stationary. Mobile is a phase that carries the sample and propels the compounds through the stationary phase, resulting in separation. While stationary phase, it is a crucial component of chromatography that interacts with analytes as they pass through, leading to separation. The most common stationary phase are silica gel, alumina, and cellulose powder. It is usually a finely ground powders or cells. Now let's go through terms. First here is retention time. It is time taken for the sample to travel from injection port through the column to the detector. And now here is elution. It is the act of forcing a mixture through a stationary phase, like a column, using a mobile phase, the eluent, to separate the components of the mixture. Next here would be eluent. It is the mobile phase that is used to carry the sample through the chromatographic column. In paper chromatography, it will be the solvent. And then lastly, finally, the eluate. It is the fluid that exits the column after the separation has occurred. It is the fluid contains the analytes, which is the components of the sample being separated along with the eluate.
Now we will talk about the method of chromatography. First one is planar and the second one is column. For the planar chromatography, it is form of liquid chromatography and it is history closely linked to the development of chromatography as an analytical tool. We have paper chromatography and also thin layer chromatography. For the column chromatography, it is used to separate and purify compound in a mixture based on different interaction with stationary phase and mobile phase. We have gas and liquid chromatography. So these are the two types of chromatography. First is planar and the second one is column. For planar, we have paper, thin layer and high performance TLC. For the column one, we have the traditional press chromatography, liquid chromatography and high performance liquid chromatography which is called HPLC. Now I will talk about the planar. First is the paper chromatography. It's an analytical method for separating colored substance. Second is thin layer. It's analyzed mixture by separating compounds. And third one is HPLC, where it separates components based varying affinity. Now for the column chromatography, first we have the traditional chromatography. It's comparatively large-scale separation into fraction, contains similar polarity. Second is gas, where it's analytical technique applicable to gas, liquid, and solid sample. Third, we have a liquid. It interacts to varying degrees with solid stationary phase. And the last one is HPLC. It combines liquid chromatography with high pressure pump.
As we choose the paper chromatography, the experiment will be focused on how to improving a lipstick chromatographic method. At first, we will face a challenge with no visible pigment transfer was seen on the paper. To fix this, we will test a different solvent, both polar and non-polar, to see how they affect pigment separation. The goal was to find a solvent that could give a clearer and more effective result.
Multiple solvents will be used in the experiment, which is acetone, 70% ethanol, 95% ethanol, 70% isopropyl alcohol, toluene, cyclohexane, and hexane. Firstly, 40 milliliters of each solvent were placed in large chromatography jars using graduated cylinder and plastic pipette. Then paper was cut 5 centimeters times 15 centimeters with 3 lines on each sheet. Baseline was drawn at 2 centimeters, 8 centimeters, and 11 centimeters. Colors were placed on 44 centimeters times 15 centimeters sheets of chromatography papers, just like the picture above me for reference. Then finally, all sheets were taped to the edge of the jar to prevent the paper tilting over. After it reached the 9 centimeters mark, we remove the paper and allow it to dry.
In this slide, compare two things. First, polar solvent like ethanol and acetone give a clearer pigment separation, while non-polar solvent like hexane and cyclohexane show a weaker result. Second, higher quality lipstick created more defined pigment bands, whereas lower quality ones show little to no separation. So, both solvent type and lipstick quality clearly affected the chromatographic outcome. In conclusion, solvent polarity and lipstick quality are both a key factor in chromatography. Polar solvent like ethanol and acetone perform a best and high quality lipstick with a better separation. This experiment shows how important it is to choose the right condition when analyzing cosmetic product using chromatography.
So here are the references that we use in the making of this slide. You can use a few of these links to make your own research when it comes to this topic of basic chromatography. Thank you for watching. Comment down below if you ever done any experiments using the chromatography method.